7 prerequisite review, numbers 13 through 18. The first two expressions that we're asked to factor here represent differences of two squares. X squared is a perfect square, 36 is a perfect square, so we can factor this as x plus 6 times x minus 6. Number 14 is the same deal, but make sure that since it's 1 minus x squared, that you set up your binomials as 1 plus x and 1 minus x. You need to have that 1 in the first position and the x in the second position, so that the product will FOIL out to be 1 minus x squared. In number 15, the means of factoring is going to involve finding the greatest common factor. Both of these terms have a greatest common factor of x in them. So if we put the expression 1 plus xy in parentheses here, we can see that its product would be x plus x squared y, and that's our final answer. In number 16, we have x to the 4th minus 1, which is, again, a difference of two perfect squares. If I think of it as x squared plus 1 times x squared minus 1. Only at this point we're not finished because the second binomial is another difference of two squares. So I have x squared plus 1 multiplied by x plus 1 times x minus 1. And that's the final fully factored answer. Number 17 has a greatest common factor of x squared. And so the expression that I need in the parentheses to get that product is y squared minus x squared. I could distribute that and see I'd be right back where I started, so this is good. Again, in the parentheses, I have a difference of two squares, so I need to factor once more. Y plus x times y minus x. Number 18, difference of two squares again. 1 is a perfect square, and 4x to the 4th is a perfect square. It's 2x squared squared. So 1 plus 2x squared times 1 minus 2x squared. And 1 minus 2x squared is not a perfect square, so that can't be factored again. And that's the final answer.